Okay, so let's start with another clustering exercise. Now here again we are using the K means clustering. Now again we are using the same, and let us first clear the output. That is, with the help of this command we can clear it. We can run this, nothing will happen. Then clustering algorithm are generally used in network traffic classification, customer and market segmentation. It can be used on any tabular data set where you want to know which rows are similar to each other and form meaningful groups out of the data set. So various examples are there, and depending on our requirement we can decide whether what type of clustering can be used in case it is required to be used. So we can run this also. Then we are going to import all the libraries, pandas, numpy, matplotlib, etc. So that also we can do with the help of this command, this code, and once it gets imported, then we can start our exercise. So k-means follows as an iterative process. So this has been done. So k-means follows an iterative process in which it tries to minimize the distance of the data point from the centroid points, right, the central points, and it's used to group the data points into k numbers of clusters based on their similarity. Euclidean distance is used to calculate the similarity. So we can run this. This is again for our understanding. That is why the explanation has been given. Now we can import other libraries which are required. That is from sklearn, data sets, samples generator, import make blobs, and then x and y are used as the variable to create this. So make blobs samples 100 and centers is equal to 5 and random state is 101, right? So this is the code which we are required to write for the purpose of doing this this exercise. Then we are going to plot PLT RC parameters. Update figure fixed size is 10 into 7.5, that is the size of the graph. And then figure DPI 100, we are considering only 100 out of the total. So scatter plot we are going to plot here, and again for that the variables are given as x. Everything is taken here, and here only 0 is taken, then here only 1 is taken, and in this say everything has been taken. So we can run it, and you can see that a good looking kind of a scatter plot will be created like this. And you can see here there are five clusters, right? 1, 2, 3, 4 and 5. And since whatever dimensions we have given, accordingly this graph got created, this scatter plot got created. This pink label that you get is something which is a kind of a alert that there may be a problem in future, so be careful. So, but there is nothing serious about it. So you can go ahead, and then as you can see from the above graph, there are 5 clusters that can be created from the data set. So we can run this, nothing will happen. Then we can also check for y. It will print the details of the y, that is the array that we have got in this. And then if you look at the value of y, you can see that the points are classified based on their clusters, but we won't be using this compute the cluster. I will be using this only for evaluation purpose. So for using k-means, you need to import k-means from the sklearn cluster library, right? So that is the purpose, but it is just for our understanding again. So now we are going to import the k-means from sklearn itself. That is all. You will see that all the libraries or sub libraries are available. Only thing that we should know that yes, it is there, and then how to use it. That's it. For using k-means, you need to specify the number of clusters as arguments. In this case, as we can look from the graph that there are 5 clusters, we will be passing 5 as arguments. But in general cases, you should use the elbow method to find the optimal number of clusters. So there is another method known as elbow method that also can be used, but depending on your requirement, whatever is suitable, that can be used, right? So this is done. Then we are going to use writing this code for the purpose of creating the cluster. So cluster is equal to k-means in clusters is equal to 5, because we are having 5 clusters, and clusters which are required to be fit into a with using X, and then we are going to predict ypred using this cluster predict X. So we can run this and nothing will happen, but yes, the internally it has created and stored the value here in ypred. Now after passing the arguments, we have fitted the model and predicted the results. Now let's visualize our prediction in a scatter plot. So now we can go for this. This of course nothing will happen here, but here with this code you will see that a scatter plot will get created. So for that, plt dot scatter x, then comma 0, here everything will be taken, then 1 will be taken, then ypred s50 and cmap plasma is the color that we are going to use, and then plt rc parameter, update figure fixed size, figure dpi is 100. So we can run this again the code is almost the same, but yes, we are getting now a colorful kind of a scatter plot having the same positions of the points, but then it's a different, so that we can definitely get better idea and we can distinguish different clusters easily. So that is how you can get this kind of a cluster also. And now we can see that the predicted clusters are mostly the same as the clusters that we saw in the initial scatter plot n, right? So this is how you can create the cluster. The objective here was to create the cluster so that we can distinguish the various parameters, various data points which are there. So that is how we can do it, right? So this completes this tutorial. Thank you.